So now we continue the discussion further, wherein I would like to explain few new concepts. Now, how the program is done? It's very simple. Multiplying two 16-bit numbers. So we already know multiplying two 8-bit numbers, right? So how will you multiply two 16-bit numbers? Number one is the result is 32-bit. So you may think of writing a big program, or once you become expert in something, it is human tendency. Everything which is new task assigned, what human being tries to do, it tries to ensure, tries its level best that rather than learning something new, whether the new task assigned can be broken into such subtasks which he already knows. Is it clear? So we already know 8-bit by 8-bit multiplication. Now we have to do multiple two 60-bit numbers. Each 8-bit number is considered to be, each 60-bit number is 2 bytes. Is it right? So can I say like this? This higher byte 1, lower byte 1, higher byte 2, lower byte 2. So what a normal person will try to do rather than inventing something new, he will perform 4 times, so partial products. So what I will do? 8000 into 8002, L1, L2. I will store somewhere. L1, L2, L1, H2, store somewhere else. H1, L2, H1, H2. Is it clear? So that you can do. There is no problem. So you can write it, code once every time, and store the partial results at, say, we want final result here. So you can use some different space where nobody will come. Let's say 9000 and 9001. What you can store? You can store L1, L2. Then at 9002 and 3, you will store L1, H2. At 9004 and 5, you will store H1, L2. And at 9006 and 7, you will store H1, H2. And while storing at 9000, lower byte, at 9000, our same sequence. So now, let us say that task is assigned to you, have to develop the entire program. Now, somebody will come to your rescue that what we want, the program is to multiply this 16-bit number and this 16-bit number, and result is to be stored here. Now, somebody comes to your help and says that no need for you to do all these things. Somehow, I will carry out the simple task of performing this 4 times. And 1, 2, 3, 4. So now what you are supposed to do? You are supposed to just write the final compilation code. लक्षात आलं काय म्हणतो मी ते? मराठीत तुम्हाला सांगतो. 8000 आणि 8001 ला एक 16 बिटचा नंबर आहे. 8002 आणि 3 ला एक दुसरा नंबर आहे. त्यांचं मल्टिप्लाय करून 4, 5, 6, 7, 8004, 5, 6 तर फायनल 32 बिटचा रिझल्ट स्टोअर करायचा आहे. तर ती प्रोसेस कॉम्प्लेक्स आहे. तर त्याचे सोपे पाठ केले. 1 word or 1 16-bit number is 2 bytes, lower byte, higher byte, L1, H1, L2, H2. So products of all 4 with 2 at a time are done, and that is stored here. So what I will do, that suppose I start the program from the beginning, initial part, that is, this is somehow done by somebody else. What somebody else has done? In fact, actually, when you work in companies, there everything from the beginning cannot be done by every individual. So you have to carry forward the legacy which is done by somebody else. So somebody else has done this part for you. What has been done? 4 parcel products are stored. Now you have to just write a compilation code. How will you write that? Is the question clear? Yes or no? Now complete the comparison code. How will you perform? So I have got H1L. Each of the parcel products are products of 2 8-bit numbers. So each of them is 16-bit. So L1, L2, L1, H2, L2, H1, sorry, L2, L2 what? Always better to write so as to avoid confusion. It works or it is means every time else it works or from our case this hello. So how to perform? L1, each of them is 60-bit number. L1, L2, H2, L1, H1, L2, H2, H1. So there are 4 16-bit numbers with you. There are 4 partial products, each of 16 bits, and you have to perform final 30-bit answer. How will you do that? How do you do that? How? Shifting. So, what will you do? This is each of them. So, this is correct. Is it the answer? If I add like this. Is it okay? Then how will you add? L2, L1 is taken directly. Then these are to be shifted by 8 bits. These to be shifted by 16 bits. How will you do that? Eight times. We have to use DAD effectively because things are 16-bit. How to do that? Is the question clear? No rocket science. अल्गोरिथम अगदी सोपा नसला तरी काय असा नॉन कॉन्व्हर्जिंग आणि काही असा हे नाही आहे. सो हाऊ टू डू? Number 1, lower byte of this partial product is the lower byte of the answer. Everybody agrees? So I start with this. So we give a final try, otherwise we have to forget this. Hello. Yeah. So where this is stored, somebody else has done and stored these partial products at 9001, 9001, 9023, 9034, 9000, 01, 2, 3, 4, 5, 6, 7. The result is to be stored at 8004, 5, 6, 7. So lower byte, this is at 9000 and 9001. So lower byte of the first partial product is lower byte of the result. So do it quickly. So this is not rocket science. So you are supposed to work. अरे वह्या आणायच्या. I hope that don't behave in a childish manner, even though you are at an advanced stage and even though म्हणजे हा प्रोसेस जरी नसला तरी आपल्याला डोकं तर चाललं पाहिजे. Participate in the class. So what we will do first? First instruction काय करणार? First and very simple. This partial product lower byte is lower byte of the result. इथं काही हे 0 आहे. त्यामुळे काय होणार? LDA किती? एवढं ते सांगा. हे प्रत्येकाला आलं पाहिजे नाही. हे जर काय नसेल तर ते ही परत प्रत्येकाला वर्गात थांबवायचं, आलं की वर्गात बाहेर जायचं, असं करायला पाहिजे. 2 तास तर 2 तास. हे तर यायलाच पाहिजे प्रत्येकाला. काय LDA किती? LDA 9000, STA 8004. बरोबर आहे. आता नेक्स्ट काय करणार? So what next will you do? How? How will you do that? These 3 are to be added. These 3 are to be added, and so things are not rocket science, but not very instantaneous and simple. So how will you do that? Using DAD. So for using DAD, what will you do? लक्षात आलं का? So this you will take. What will you do? Now try to first is done. LDA 9000, STA 8004 is over. LDA 9001, move A, E. MVID 00, LHLD बरोबर, LHLD 9002 हे आला. आता हा नंबर काय केलाय, हा नंबर कसा, हायर बाइट ऑफ फर्स्ट पार्शियल प्रोडक्ट इज ऍक्टिंग एज लोअर बाइट नाउ, शिफ्ट केलाय, हा शिफ्ट केलाय, तेव्हा दिस प्लस दिस एवढंच करायचं आपल्याला. सो दिस इज टेकन इन E, this is 0, so D is made 0, this is taken in HL. Now we will do that D, आता after that D what, after that D we have to add, now we have to add, these two are added, so this is a 16-bit number. Now there are many challenges. What are the challenges? Carry will come, carry may come, and in that we will add this. So that time also carry may come, and if carry comes in either of the processes, if carry comes in either of the processes, we have to add that carry here. So is idea clear? So you have to develop a foolproof program for this. So what will you do? Now here we will make MVIC 00. Here we say jump on no carry skip. Here we make MVIC 01. MVIC 01. Here is skip. At skip what you do? At skip what that? This number is not yet loaded. So you have something in HL, in that you have to add this, but this you can't load in other register pair, otherwise you have to go for LDA. So you can exchange. So you are aware of the last time instruction. So exchange. Then LHLD 9004. After that that D. Then jump on no carry, we put ahead. At here MVIC 01. At ahead what will you do? At ahead what will you do? This is to be stored. This plus this is to be stored at 8005. 8005. Then this is to be loaded 9007. LDA. Then in that what?
ADCC.
Not ADC now. Add C. If C is 0, nothing will be added. And then STA. Is it right? So this is the program. Now just we try to work on a new issue. But now the problem is what was told to you, that This one, that is. This part was done by somebody else for you. Now if you have to do that, what will you do? Each time you will write the code, previous code, so that you write 4 times. So now don't you think that it is unnecessarily repetitive work? So repeating the code every time is non-efficient way of programming. So what will you do? Repeating the code is a non-efficient way of programming. So what will you do? You will write that at some other place. Well, let's try to listen now. What we are required? 8-bit into 8-bit multiplication. This I have to use 4 times. 8 by 8 multiplication program. I have to rewrite the same code again and again. 4 times, and it may be required many times. So what I will do? I will write it somewhere and use the same thing again and again. So while defining that, what I will do, that I call as a subtask. So that I will write at some place, say my main program starts from 0 and I will write that at 3000. So what I will write? I will write the entire code. So when I write a code, when you join a company, code is not important, its documentation is important, because when you write the code you know, but if somebody else is using that code, he doesn't know from the code. Comments are important, that documentation. So this is a subtask which I am going to write. So what that subtask I will write? The subtask will be provided 2 numbers, one in A and one in E. The subtask is to be invoked with, म्हणजे invoke means to be invited, to be initialized. आता invokeचा exact अर्थ डिक्शनरी तुम्ही करा. Is to be invoked with 2 numbers. Means what this subtask does? This subtask multiplies 2 8-bit numbers given in A and E and gives back the result in HL. This subtask is to be invoked. The parameters to be supplied as input to it are in A and C, and it returns the result in HL. To be supplied with A and E, it gives back the result in HL. So now what I will do? Initially I want what multiplication? LDA 8000. At 0003, move E comma A. LDA 8001. So L1, L2. L1, L2 are there. Then I will jump at 3000. Here is my code. Right? So that code gets over, let us add that 8-bit shift and add method you did. So that code, let us say, gets over at 3011, it gets over. So now here what should be there? Return, I think, since we, how can you say return? Right now I have jumped at 3000. So here what I should have? Jump back. Where? 4, 5, 6, 7, 8. So I should have jumped. There is a problem now. What is the problem? Okay, that you did. We will not say the negative angle. We proceed, and we say a problem is there and problem comes. So next what? So it comes here, let us say. So result is in HL, where I have to store that 9000. So SHLD हे काय चाललंय कळलं का? काय चाललंय? 16/60 बिट मल्टिप्लाय आपण केलं, पण कुठून केलं? पार्शल प्रोडक्ट कुणीतरी करून दिले ते आता आपण करतो. नाउ नेक्स्ट व्हॉट? 898898000B LDA 8000. अरे आता चूक झाली. काय चूक झाली? 8002 पाहिजे. LDA 8001 B C D E move A to E F LDA L1 L2 L1 L1 H2 F01, so 00 1 2 jump 3000. Right, so what I have done, I have put L1 in E, L2 in A, and I went there. So it did my multiplication. I came back, I stored the result. But now the problem is, when I jump from here to 3000, it will do everything. It will perform multiplication, but it will go again. It is expected to come at 1 2. It is 2 3 4. I am expecting it to come back at 15. It is will go at 8. Right? So this is something which is of no use. Is it clear? So unless I have got, so what is the problem? This subroutine, subtask which I am going to use repeatedly, I will go there from different addresses, because the address to go is fixed, that is at 3000. But once it finishes that, from there it should come to the next address from where it has gone. So what we should have now, we must have a very different instruction. So the problem is for branch we only know jump instruction, where jump instruction provides me what jump instruction provides? Jump instruction provides me direct branch instruction, means where I should go is to be there as a part of the instruction, so that one's program is fixed. Now what can you do? So at 3012 I am having C3, then here I have 0800. So before this jump, can you do something? This is called as dynamic programming. बघा लक्षात लगा, म्हणजे ही instruction आहे की नाही, the instruction at the end of the subroutine is jump. Jump instruction at 3012. with 3012 ला काय आहे, जम्पचा ऑपकोड तो किती आहे, C3. नंतर 3013 ला काय असतं, लोअर बाइट व्हेअर टू जम्प, आणि 3014 ला काय असणार, हायर बाइट. आर यू गेटिंग मी? 3012 ला ही इन्स्ट्रक्शन आहे जम्प, म्हणजे ऑपकोड जम्पचा. हे कुठं असतं, 3014 13 ला, आणि हे कुठं असतंय, हे कुठं असतं, इथं 0 0 इथं 0. लक्षात आलं? मग आता तिथं गेल्यावर ही इन्स्ट्रक्शन जी जंप आहे ती म्हणजे that jump instruction is branching to the word written. Listen very carefully, I am trying my level best. 3012 ॲड्रेसला जंपचा ऑपकोड असेल C3, तर ती इन्स्ट्रक्शन मला कुठल्या ॲड्रेसला घेऊन जाईल की जो वर्ड 3013 आणि 3014 ला स्टोअर केला असेल तिथं घेऊन जाईल. जंप इन्स्ट्रक्शन which is written at 3012. Jump is how many byte instruction? 3 byte instruction. First is opcode C3 which is at 3012, and at 3013 and 3014 there will be some values, so that will take me to that address. Then you tell me what can I do so that the problem is solved. Before this jump you will write something. One instruction you will add, 2 instructions you will add. Two instructions you will add, so that now here I will add some. आणि हे आलं पाहिजे, पण सगळ्यांना लगेच येणार नाही, पण त्या दिवशी विचारायला पाहिजे. आय विल प्रॉब्लेम काय लक्षात आला का? हे सगळं का चाललंय? जो पार्ट हा आता इथं हा छोटा आहे, असे मोठे टास्क होऊ शकतात. जो पार्ट मला सारखा लागणार आहे, तर तो प्रत्येक वेळी न लिहिता मी एकाच ठिकाणी लिहिणार आणि ठिकठिकाणी तो रेफर करणार. आता म्हणजे युट्यूब सारखं आहे. आता समजा तुम्हाला हे बघायचं आहे, हे लेक्चर बघायचे आहे, तर प्रत्येकाला ती पेन ड्राईव्ह न्यायला लागते. युट्यूब काय करणार आहे, एकाच ठिकाणी स्टोअर्ड आहे, त्या लिंकवर तुम्ही तिथूनच घेणार. काय तसं इट इज ॲट वन प्लेस, एका ठिकाणी लिहिलंय. पण प्रॉब्लेम काय आहे, मी इथून तिकडे चाललोय, ते संपलं की मला पुढच्या ठिकाणी परत यायचंय. मग इथली इन्स्ट्रक्शन जी आहे ती अशी जंप इन्स्ट्रक्शन आहे, ती डेस्टिनेशन ऑफ जंप मी गजर अलार्म लावतो. म्हणजे काय, मला किती वाजता उठायचंय ते मी तिथं फील करून ठेवतो झोपण्यापूर्वी, का नंतर माझ्या काय सांग. सो दिस इज द रिटर्न ॲड्रेस. The last instruction of the subroutine is jump instruction. Jump is an instruction which is having opcode and operand. So the destination operand of jump instruction will be suitably changed by me before I branch. मी इथं काय करणार, या जंप पूर्वी इथं मी 2 इन्स्ट्रक्शन्स अशा लिहिणार. त्या काय असणार, मी परत पुन्हा 8 ला परत येणार आहे, पण त्या इन्स्ट्रक्शनला तुला काय होतोय त्याने पुढे जाते. मी आता तेवढा वेळ आपल्याकडे नाही आहे, तर आता मी काय करतो, त्या इन्व्हर्स इंजिनिअरिंग मी लिहितो. म्हणजे प्रश्न सोडवा नाही, प्रश्न दिलेला आहे, त्याचं उत्तर दिलेलं आहे, दिलेलं उत्तर त्या प्रश्नाचं आहे याच्याबद्दल स्वतःची खात्री करा. you understood this. So what I am doing, LDA, that is okay, so operands are taken. Now I want to go to subroutine. From there I want to come back. From there I want to come back. So what I will do, LXI H000E is this. That I will store at this instruction. The instruction मी लिहिताना प्रोग्राम लिहिता अशी लिहिणार. इनिशियली काहीतला मीनिंग नाही आहे. This will do, it will store 0E, म्हणजे इथं 0E आणि इथं 00 स्टोर होईल. This instruction would be jump 000E. आधी LSB व AMS. So LXI H000E SHLD 3013 will make this instruction jump at 000E, which is the next address after this. So this jump will take it here and this jump will bring it here. पुन्हा जेव्हा असेल तेव्हा मी काय करणार? This I will change. Right? So each time before I go to subroutine, its return address I will modify. Then there are two issues here. What those are? Number one is that each time I have to do this two unnecessary instructions, number one. And number two is that this subroutine must reside in a typical type of memory. What is that? Subroutine must reside, and this is a major limitation. Subroutine must reside in typical type of memory. What is that? It must reside in read-write memory. Subroutine must reside in read-write memory. If that subroutine is residing in the read-only memory, you can't modify that. Means that this is not, no doubt is a correct way if subroutine resides in read-write memory, but this is what we can say dynamic programming, or it is not so proper. No doubt it's not it's wrong, but this is not a good practice to be followed, because that this somebody else will not be able to understand that code, because earlier part of the program is changing the code itself, which is something will not be understood in a proper manner. Therefore, this is something not so good. So there must be some instruction. There must be some instruction which will be providing me an indirect jump instruction. There must be some instruction which should be providing me an indirect branch, and for that purpose, let us say that there is some register inside a processor. Let us say some additional register, we can say. That additional register I will name as return register. A 16-bit register, return register. Let us say now I am telling you this is good, but problem is it must be in read-write memory. Many times not. Some routines are there fixed to this. So I will provide additional register, a register return, additional register I am telling. And there is another pseudo instruction as back. What is back instruction? Back instruction will provide indirect branch. that is back instruction, it will make the program counter equal to return register. So what I will do, here I will write, this is not required, LXI return, it is hypothetical, LXI return 000B LXI रिटर्न म्हणजे रिटर्न आहे एक डमी रजिस्टर आहे असं धरला आपण वेगळा LXI return 000B and at 3012 we are having another instruction back. So what back instruction will do? Back is jump instruction and it will jump to the local value in return register. So it will work very appropriately then. From here what I am doing, I am 0 where I want expect return, that I am putting in this additional register, and this is a fixed instruction now, back. Fixed in the back. I will come here. But again there is a problem. The problem is this addition I have to do each time, but that is okay. But it may happen so when we grow further, one task is to be done by some subtasks, but that subtask may itself be huge. Atta chota hai. Subtask may be huge and that may require to go for other subtasks. बघा लक्षात आहे का आता? म्हणजे आता मेन प्रोग्राम मध्ये मला सब रूटीन 4दा लागणार आहे. मी जातो येतो. आता असं आहे की सब रूटीन जे आहे ते पण साधं नाही आहे, ते खूप मोठं आहे की त्यामध्ये सुद्धा मला आणखीन एखादं टास्क पुन्हा लागणार आहे. मग तिथं प्रॉब्लेम आला का आता रिटर्न रजिस्टर एकच आहे, मग हा एक आहे, हा यूज झाला इथं. मग या सब रूटीन मध्ये इथं हे 3000 पासून मला एक 4000 मध्ये सब टास्क आहे. मग मला इथं जायला लागणार आहे. मग इथं आता मी रिटर्न वापरू शकत नाही का? इथं वापरलाय, मग काय करायचं? So the issue is that if I am required to use nested subroutine, this is the concept of nested subroutine, what I am required to do, and that is solved by the concept of stack. So stack pointer and stack is a dynamically pointed data structure wherein the stack top itself is a variable in the memory and that address is automatically managed. We'll continue next time. Attendance.